We briefly mentioned the ROS launch system when we were talking about the command line tools. In this video, we're going to dive a little deeper into it. The launch system lets us run nodes, set parameters, control how logs are stored, and much more. We do all this by creating files that hold the details of how we want our system set up. There are three languages we can write these launch files in: Python, XML, and YAML. In this video, we're going to look at Python and XML launch files. To add launch files to our RJ training package, we'll need to create a folder for them called launch, and tell our build system to install that folder into our package's shared resources destination. So we'll add a new folder to the RJ training package folder called launch. Then we'll open up our CMake file, and in front of our build testing block, we'll add a new call to install. We'll tell it we're installing a directory named launch to the destination share/the name of our package using the project name CMake variable. Now we can create a launch file in this directory and it'll get installed to the right place when we build our package. Let's start by making a simple XML launch file. Here's what an XML launch file looks like. The top level tag is always the launch tag. So every XML launch file will start with an opening launch tag and end with a closing launch tag. Within that tag, we have two node tags. The node tag will start a ROS node given its package name and executable name. We give those names as attributes of the XML tag. So here we're starting two nodes. The first node is from the TurtleSim package and is the TurtleSim node. We've started that one manually before. The second one is also from the TurtleSim package, but now we're starting the drawSquare node, which will move our turtle around in a square. To use this launch file, we'll need to build our workspace with build, source our overlay setup script, and now we can run ROS2 launch RJ training demo.launch.xml. When that starts, we see our turtle and we see it moving in a square. Both nodes are running in this one terminal controlled by the launch file. When we press Ctrl+C in that terminal, the launch file will catch that signal and shut down both nodes for us. Launch files also let us set parameters for individual nodes, so I've added some parameter tags to our simple launch file. Here I've expanded the TurtleSim node tag, breaking it up into a start and stop tag so that I can add some children to it. In this case, 3 param tags. Every param tag takes the name of the parameter we want to set and the value we want to give it. We mentioned in the parameters video that certain parameter overrides will be available to the node in its constructor. This is an example of where those parameter overrides can come from. So if we build and launch this new version of the file, we should see that the background is pure green as opposed to the default blue. And that's exactly what we get. Now, launch files don't just have to set parameters to static values. Launch files can take in arguments themselves, and then forward those arguments along as parameter values, or do other kinds of calculations based on the argument values. Here, I've added 3 arguments to our launch file, one for each of the background color parameters that we'll be forwarding to the TurtleSim node. Each arg tag takes in a name for the name of the argument, and a default attribute that specifies the default value we want it to have. To use the value of an argument, we can use a special substitution expression. Substitution expressions start with a $sign open parenthesis and then a close parenthesis to end them. Inside of this expression, we can use a variety of keywords and variable names. In this case, we're using the var keyword to say that we want the value of a variable available in our launch file, and then we're giving it the name of one of the arguments that our launch file takes in. This whole substitution expression will get evaluated to the value stored in background B when we launch the file. Then that value will get passed on via the parameter tag to the background B parameter on our TurtleSim node. So once again, we'll build our workspace to get the new version of the launch file. But this time, we'll pass in a value for the background B launch argument from the command line. To do that, we simply specify the name of the argument, and then use : to set it to a new value. Let's say 255. And when we launch that, we get TurtleSim with a new background color. The red and green channels are still at their respective defaults of 0 and 255, but the blue channel now has the value we specified on the command line. This is what a usual XML launch file will look like in ROS. A couple of arguments generally declared at the top, though they can be anywhere, and then a variety of nodes, often passing in parameter values derived from those arguments. Now let's make a new launch file using the Python syntax. And here's a simple launch file using the Python language. Notice that the file extension has changed. Our previous file was called demo.launch.xml, and the new file is demo2.launch.py. The style of these file names is not a strict requirement, but it's a good convention. Like any Python script, we start with some import statements. In this case, we're importing two utilities we'll be using from the launch and launch ROS packages. The launch package defines the behavior of the general launch system, and the launch ROS package defines all the ROS-specific launch utilities. Every Python launch script has to define a generateLaunchDescription method. This is the entry point for our script that will be called by the launch tool. The important thing that this function does is return a launch description object that holds all of the information about what nodes to start, how to configure them, and any other actions we want this launch file to take. The easiest way to construct that launch description object is to give it an array of launch actions. Here, we're giving it two actions in the form of two node objects. The node action tells us that we're going to be starting a ROS node, and we can do that given the package name and the executable name. With this launch file, we'll start the same two nodes we were doing with the XML launch file. So now we can once again build our package to get this new launch file and use the ROS2 launch command with the RJ training package name to launch demo2.launch.py. And again, we get our two nodes running with all default parameters. And of course, we can change those parameters to some non-default values. To do this, we just need to add another argument to the node action called parameters. This will take an array of different parameter sources. The simplest source is just a Python dictionary. So I'm creating that array, then creating that dictionary, and inside of that dictionary are simply the names and values of the parameters I want to set on the TurtleSim node. And I'm setting them here to the same values we were using in the XML node so that we get a plain green background. Now when we build and launch our Python launch file, we see that those parameters took effect and we now have a green background. The Python syntax can also take in launch arguments. To do this, we'll need to import two more utilities. We'll need to import declareLaunchArgument from launch.actions and launch configuration from launch.substitutions. The declareLaunchArgument action tells the launch system that we are interested in receiving an argument with a certain name and a certain default value. So here I've added 3 instances of that action to declare each of the 3 background parameter values that we're interested in receiving as launch arguments. To get the value of that argument, we'll use the launch configuration utility with the name of the argument. By using launch configuration instead of the hard-coded values in our parameters dictionary, we are now forwarding the values of these arguments to the node's parameters. So just like before, we can build our workspace to get the new launch file. And we can launch that launch file and give it the name of our argument, in this case background B, := the new value, again 255, and when we run it, we'll see that argument take effect and we'll get a different background color in TurtleSim. The launch system can do a lot more than just start nodes and set parameters. The Python interface in particular is incredibly powerful because you're running an actual Python script, so you can do pretty much anything you want. Even with just the launch API though, you can run non-ROS applications, set environment variables, and set nodes to restart automatically if they crash. Most launch files though are pretty simple like the ones we wrote today.